I want us to look at this concept of differentiation. Differentiating is also called finding the derivative. Another name for finding the derivative is finding dy over dx. That is if the equation starts with y and then we have the x in that equation. So we normally use this formula. If y is equal to x power n, then the derivative, which is also called dy dx, or the ingredient function, that is dy over dx, or dy dx will be given by, you take this n to be the coefficient of x, so you start with n x, and then the value of n which is given here, you subtract 1. So the formula is dy over dx is equal to n x n minus 1. This is the formula for differentiating. And let's apply that formula in doing some examples here. The first one, we have y is equal to x squared. So as you've seen in this formula, you take 2. Our value of n here is 2. So you take 2 and start with it. So you'll have 2x, and then the value which is the value of n here, you subtract 1. So that will be 2 minus 1, which is 1. So basically when you have 2x power 1, you can just leave it as 2x because that implies 2x power 1. Another example, you have y is equal to x power 6. So as you've been doing, take n to be the coefficient of x. So our dy over dx will be, take 6 here. So you'll have 6x and then subtract 1 from 6. That will be 5. 6x power 5. The next example, y is equal to x power 3. You take the value of n, which is 3, you take it to the start. So your dy over dx, or the derivative, will be 3. Then you have x, then 3, subtract 1, you will have 2. So that will be your derivative, or your derivative after you differentiate. Another example, you have y is equal to x power 4. So your dy over dx will be, take 4 to be the coefficient of x to start there. So you'll have 4x and then subtract 1 from 4. You'll be left with 3. That is the next one. We have another example, y is equal to x power 10. Take 10, let the 10 hapa mwanzo, you have your dy over dx, which will be 10. You've taken 10 here. The next thing is to subtract 1 from 10. So you have 10x power 10 minus 1 is 9. So you have 10x power 9. Another example here, y is equal to x power 6. So as we've been doing from this formula, dy over dx, or the derivative, or the ingredient function, is given by, take the value of n to the start. So you have 6x power 6 minus 1 is 5. That will be your next solution. And this is the dy over dx. Y is equal to x power 9. What is dy dx? You'll have your dy over dx as 9x. You take 9 here. So you have 9x, then 9 minus 1 is 8. So that is 9x power 8. Next we have y is equal to x power 20. So your dy over dx, or the derivative, will be 20x power 19. To get that, you just take 20 here and then subtract 1 from 20 in the power of that number. Then we have x is equal to x power 3, y is equal to x power 3. Your dy over dx will be equal to, you take negative 3 to start, so you have negative 3x. Then you have negative 3 minus 1, which gives you negative 4. So you'll have negative 3x minus 4. Next example, we have y is equal to 8x power 5. To get your dy over dx, you will have take 5 to the coefficient of x, and when you take 5, if there's another number here which is not 1, you multiply. So you'll have 5 times 8, which is 40. So you'll have 40 x power 5 minus 1, which is 4. 40x power 4. Lastly, we have y is equal to half x power 4. What is your dy over dx? Your dy over dx will be 4 times half. 4 times half will give you 2. And then you have x. 4 minus 1 is 3. 2x power 3. So that is how you differentiate. It's very simple. You only need to follow this formula, which is dy over dx is equal to the value that you have for the power. You start with it, n x, then n minus 1. That is how you get the derivative of a function. The derivative is also called dy over dx, and it is also called the ingredient function.